You guys are lucky you're here for the most fun, entertaining, interesting talk of the day. Probably. Who knows? I have no idea. I thought this would be fun. So, quick question. How many of you are familiar with JSON Web Tokens? Just throw your hands in the air. Awesome. Cool. It's pretty good. If you're not, by the way, don't worry about it. It'll still be fun for you. And second question, which is going to sound a little weird, but how many of you are cool if I use some swearing tonight? Just throw your hands up in the air again. Great. This is going to go over a lot better than my last talk then, for sure. So, I'm Randall, and I'm here to talk to you guys about why JSON Web Tokens suck and are also stupid. And this isn't really a talk so much as it is just like a rant, me getting things off my chest. I've always wanted to do this, so now I have the opportunity, and you have to listen to me now that you're here, so this is fantastic. Now, I know some of you probably use JSON Web Tokens and like them, and you came to this talk because you said, well, why would someone be talking shit about them for 45 minutes, right? And it's a valid question. And that's why, at the bottom of the screen over here, I have my personal Twitter account and my company's Twitter account. So if you get angry, you can feel free to tweet hate at me during this talk. That's fine. I don't mind. I have a pretty thick skin. I can take it. So do your best. Now, quick background on me. Why should you listen to me? Well, my name's Randall. Mentioned that before. And I work at this company called Okta. And I've been basically building security tools for web developers for the last 5 years in a row. I've been designing authentication libraries, authorization libraries in Python, Node.js, and Golang. Those are my 3 primary technologies I work with. And then for the last 15 years before that, I've been involved in the security industry, primarily working on operating system security. So that's my background. And today I do a lot of open source projects in those languages on the screen. Now, let's talk about what JSON Web Tokens actually are, just to get started, before we get into the fun stuff, okay? That way we all know the same thing. Now, JSON Web Tokens are abbreviated JWT. You can also pronounce that shortened acronym as JWT, just FYI. So I'm going to use these terms interchangeably, so just so you know. Now, what is a JSON Web Token? It's basically JSON data that's been cryptographically signed, and the 2 important things that people should know about JSON Web Tokens is that they're not fancy. So whenever you read an article telling you JSON Web Tokens are awesome or whatever, you just have to realize it's just JSON data. It's not cool, it's not fancy, it's just plain old JSON data. It's really nothing special in terms of a protocol. And then the second important thing you should know about them is that JSON Web Tokens are not encrypted. So what does that mean? Well, it means that if I have a JSON Web Token with some sensitive data inside of it, and I give it to you or you store it in a web browser, whoever has a copy of that token can see all the information you've ever put inside of it. So a lot of people tend to think JSON Web Tokens are some security protocol and whatnot. That is not true. They're not designed for this purpose. Now, there is a way to encrypt JSON Web Tokens, but in almost 99.9999% of cases, they're not. So just keep that in mind. Now, because we mentioned cryptographic signatures, let's talk about those. What is a cryptographic signature? Well, think of it like this. Let's say that I write a letter. So I type a letter up, and I print it out, and then at the bottom of the letter, I sign my name, and I mail it to you. When you get that letter, what do? Well, you read the words, and then at the bottom, you look at my signature, and you know my name, Randall, so you see that, and you know what my handwriting looks like, and so you say, well, hey, I trust that this is Randall because I know what his signature looks like, and therefore I trust all the information that was typed up on the page. And that's basically what a cryptographic signature is. It's just a way to verify that some data was generated by a particular person. That's all cryptographic signing is. Now, what do JSON Web Tokens do? Well, basically, they prove that some JSON data can be trusted. They prove that JSON data is legitimate, essentially. And the best way to describe this in real life, the best analogy, is every time you go to the airport, when the TSA asks you for your identification and you hand them like your California driver's license, they're going to look at that. They're going to see your height, your age, your weight, your eye color, all these different things about you. That's like the JSON data on your ID card. Then they look at the license and they say, well, it has the stamp of California on there. They know what California is. They know what the ID is supposed to look like. They know what the watermarks are supposed to look like. And so they trust that the data on the ID is valid. So tokens, or JSON Web Tokens, are basically passports, identifiers, things like that. Now, how do people typically use JSON Web Tokens? Well, I can almost guarantee most of you are here because most people use JSON Web Tokens as identity proof. They use it to log someone into a website and manage their identity. That's the main use case that people have adopted them for today, excuse me, and that's what I'm primarily going to be talking about. Now, you can use them for lots of other things, but this is the big one that people care about. Now, there's two ways that people use JSON Web Tokens for identity. Both ways are pretty normal, but the first way, the way I'm describing on the screen right here, is by far the most common. This is what you'll see in almost every website tutorial, blog post, Udemy course, whatever, is what's on the screen right here. And let me just walk you through it real quick, because it's important to know. So, when a user logs into your website, they typically go to a login page. They enter things like their email and password, and they hit submit. Those credentials are going to get transmitted from your browser to the web server that's running the website. The web server is going to validate your credentials. It's going to make sure your password's correct and your email is correct. Then it's going to generate a JSON Web Token for you and store all of your user information inside of that token as JSON data. So if your user account has like a first name, a last name, a username, a birthday, stuff like that, that will all be encoded in this JSON data in the JSON Web Token. Then, when the website sends that response back to the browser that actually logs you in, that information is going to be picked up and stored inside of HTML local storage, which is just a JavaScript API that runs in the browser, and it's going to take this token, which is just a big long string, and store it inside of local storage. And then from this point on, every time you need to make a request back to the website from your browser to like view a dashboard page or view a billing page, if you need to re-identify yourself, if it's a page that requires login, you're going to use some JavaScript code to pull that token out of local storage and send it to the website to re-identify you. It's basically like a session. Does that make sense to everyone? Cool. Now, the second way people use these things is exactly the same thing I just described with one minor difference. Instead of storing the token inside of local storage in the browser, the token will be stored inside of a cookie. And cookies, we're going to get into it later, but they're not used for JSON Web Tokens very often for numerous reasons, which we'll get into. So just keep these in mind as we go through this. Now, here's the fun part, all right? What happens if you Google JSON Web Tokens? Anyone know? Just shout it out. Was that hate articles? No, actually. Exactly the opposite. Everybody fucking loves JSON Web Tokens, you guys. Everybody's in love with these things. There's a million blog posts, YouTube videos, tutorials on Pluralsight and stuff teaching you how to use JSON Web Tokens to log into websites and why it's the most secure thing and why it's really cool and fast and efficient and scalable and all these things. And what's crazy about this is that everyone is wrong. So all these things are completely inaccurate. They are the wrong way to do it. And this is one of the reasons why security on the web gets such a bad rep, is because most people have no idea what they're doing. And that's okay. But it's also a little funny to me. And what I find particularly interesting is that even in the security industry amongst my peers, I oftentimes feel like I'm taking crazy pills because a lot of people legitimately love JSON Web Tokens, and it makes me feel absolutely insane. So my selfish reason for coming here tonight is really to just sort of like pitch you guys my idea about why I think they suck, and hopefully get some of you to agree with me to validate that I'm not in fact crazy. So that'd be fantastic. Now, the second part of this story is that it's not really the JSON Web Tokens that I hate so much as it is that I think the real tragedy of this story is that we have all collectively forgotten how amazing sessions are and session technologies. And I think that's the real moral of the story I'm going to be telling you tonight, is why sessions are so much better than JSON Web Tokens in every single possible way, and why JSON Web Tokens just fuck things up. So that's the idea. Now, before we get into all the reasons, and there will be a lot of them, let's quickly talk about some terminology so we're all on the same page. Now, I absolutely hate defining terminology, but in this case, I'm going to make it as pleasant as possible. So if you don't understand something, throw your hand up and ask a question, and we'll power through it. Now, first off, let's talk about JWTs. There's two different kinds of JWTs that people use. The first one is called a stateless JWT. This is by far the most common type of JWT you will encounter. Stateless JWTs are what I described before. They're a JSON Web Token that contains all of your user information inside of the JSON data of the token. So if you have an email, a first name, a last name, and a favorite color, those three fields would be encoded in the JSON Web Token as JSON data. Now, how do these work? Well, let's say you have a user who's logged into a website, and the user wants to view a page on the website. So he says, hey, let me see this page. When he makes that request, he's going to be sending his JSON Web Token along to the website to identify himself. The website when it receives the request, is going to validate this token. And what do I mean by validation? I mean it's going to check the signature and say, hey, do we trust this JSON data inside of this token? That's the benefit to that cryptographic signature stuff we mentioned before. Then once it's been validated, it's going to look inside the token and extract the JSON data. It's going to say, well, hey, I see you have an email in here. I see your first name, your last name, your favorite color, all this data about you. I have it. Then finally, the website is going to show you a page that you were requesting, maybe a dashboard page or a billing page. And it's going to use your first name and last name and all those other variables from the token to render the page and then display it to you. And that's it. Makes sense, right? Cool. Now, at the opposite end of the spectrum, we have a stateful JWT. Now, what is a stateful JWT? It's basically the exact opposite of a stateless JWT, okay? It's a JWT that only contains one piece of JSON data, a session ID. And we'll take a look at how this looks right now. So in the exact same scenario, the user with a stateful JWT wants to view a page. So what happens? Well, the website is going to validate the token again, and it's going to extract the JSON data and see one variable, a session ID. Then the website is going to talk to some sort of database. Now this might be Postgres, MySQL, MongoDB, CockroachDB, DynamoDB, local memory. Could be anything, but is basically going to say, hey, we need to come over here and see where this user is in our database. You're going to find the user based on the session ID, return the info to the web server, and then finally the web server is going to render a page and show it to you. This is like your traditional like server-side web application. Does that make sense to everyone? Pretty good. All right. Now let's talk about session cookies. So session cookies is the same sort of technology, except instead of using JSON, we're just storing the session ID on its own inside of the browser. So there's no JSON Web Token in this scenario. There's just a session identifier. And let's see how this looks. So the user is going to make a request to a website to view a page. The website is going to look at the session identifier. The session identifier is also going to be cryptographically signed. So one important thing to know about JSON Web Tokens is that JSON Web Tokens are really two things, remember. They're JSON data with a cryptographic signature, right? A session cookie is just data, like string data, with a cryptographic signature. So the only difference between the two, there's a few, but the main difference is that the type of data that's being used. Does that make sense? So we're going to validate the signature, see the session identifier, talk to the database, get the data exactly like before. Now you might be wondering what the difference is between a session cookie and a stateful JWT, because those two look an awful lot like one another. It's a good question. And I'll tell you what's the same between both of them, right? They're both cryptographically signed, as I just mentioned, which means we can trust whatever data we get back from them. And they both contain a session identifier. They contain the same information. The main difference is that, again, one is JSON data and one is just a string. And this is really important to understand. Everyone following so far? Cool. If you're confused, by the way, just shout out. No big deal. All right, now, next up, let's talk about cookies. So I absolutely love cookies. They get a bad rep today. But cookies are pretty cool because they let you store some data in a browser, and they're basically like the OG of like NoSQL. So cookies are like the very original like NoSQL database of the web. That's what they are. They're built in 1994, and they basically just store key value data in a browser, and that's it. The only difference between a cookie and MongoDB is just how much data it can store. Cookies can store 4 kilobytes of data, and that's it. Now, okay, there's probably a few other subtle differences between this and MongoDB, but honestly, at the end of the day, not much. They're basically the same shit. So, remember that they only store 4 kilobytes of data. Now, how do we actually use cookies? This is important to know. So, when a user logs into your website, for instance, if you want to create a cookie so that you can remember who the user is, here's how you do that. The user says, hey, website, let me log in. The website's going to log the user in, and when the website sends a response back to the user's browser, it's going to contain the body of the request, right? Like a thank you message or whatever, or the dashboard page. But more importantly, it's going to return this header, this HTTP header called set-cookie. And the value of this cookie is going to be the cookie's name, which in this case is session, an equal sign, and then the session ID. So like 1, 2, 3, 4, 5, for instance, just a random number that's been cryptographically signed. Does this make sense so far? This is how you set a cookie. It's just a simple key equals value declaration inside of an HTTP header. Now, if you want to create multiple cookies, for instance, then you would just use this header format. Use the same exact format, and you can say, you know, A equals B. That will create a cookie called A. Then you could create another cookie called C and assign its value to D. So you can create multiple cookies at once using this syntax as well. And again, these are just HTTP header fields, so really, really basic. Now, I do want to take one quick moment to explain some important security things about cookies. So cookies on their own are basically useless unless they have these things called cookie flags attached to them, which greatly improve their security. Now, here's a fun question. What's the most dangerous thing in the entire world for web security right now? The most dangerous thing in the world is JavaScript. JavaScript is the worst, okay? So running JavaScript code inside of a browser is basically like playing with a gun in your backpack. It's just a really, really bad idea because JavaScript is an unsafe language to use. It's very hodgepodge together. I know everyone here loves JavaScript, but I'm just telling it like it is, right? It's sort of a shitty programming language, I'm sorry. So we have to do things to prevent JavaScript from accessing your sensitive information at all costs, okay? And this is what some of these cookie flags do. So what cookie flag should we always tack on to the end of this HTTP header declaration? Well, the first one is called HTTP only. This is my personal favorite because basically what this tells the browser is, hey browser, store this cookie data, but never let JavaScript code access it. And I think that's just amazing. Because like I said, JavaScript is super dangerous. You should never have anything to do with it. Now, the next cookie flag that's really great is the same site flag. This helps prevent something called cross-site request forgery. It's an attack pattern. We're going to talk about it later, but this will help you with that. And finally, this gentleman over here mentioned SSL. SSL is definitely mandatory every time you are doing stuff that involves sensitive information. You always need to use it. And if you add this secure flag onto your cookie definitions, the browser will refuse to create a cookie if it was not set over a secured connection over SSL. So these are all super useful. Now, we talked about creating cookies. Let's talk about reading cookies. So once the browser has a cookie stored inside of it, and the user is using your website, making requests to different pages, how do you, as the person building the web server, actually parse the cookie data out? Let's talk about that real fast. Well, basically what ends up happening is every time the browser makes a request back to the website, it's going to pass in this header called the cookie header. Now, if you notice, this is the exact same data we had before, except the name of the header is cookie instead of stat-cookie. And in my opinion, this is actually pretty damn sweet. This is pretty nice. It's really clear, it's really simple. It just says cookie. I mean, come on, what else do you want? It's pretty fantastic. And so what do? Well, when we receive a request like this, we're going to parse out the cookie header. We're going to say, hey, we see this header called cookie. We see the data inside of it. We extract, we separate on the equal sign. We split the string up, and we say this equals this. Easy, super simple. Now finally, the last term we're going to talk about, I know this is the boring stuff. Bear with me. Is HTML local storage. How many of you are familiar with local storage? Please raise your hand. Okay, great. Well, local storage, again, is a JavaScript API that allows you to store key value data. It's basically the exact same thing as a cookie with two minor differences. Difference number one, well, three differences. Difference number one, it can store up to 5 megabytes of data instead of 4 kilobytes of data. So there's a big size differential. The second thing is that local storage only works inside of JavaScript. And then the third thing is that you need to actually write JavaScript code to put stuff into it and take stuff out of it. So just keep that in mind. We're going to reflect back on this periodically. So now for the fun part. Let's talk about all the myths about JSON Web Tokens. Now, these things have all come from like real-world conversations I've had with developers over the last 3 years or so. And these are things I actually hear on a fairly consistent, regular basis. So I thought it would be fun to just debunk them all one at a time. Now the first thing I want to talk about is a lot of people say that JSON Web Tokens are easier to use than traditional server-side sessions. And so let's talk about that. And the best way to talk about this is to just look at some history. So JSON Web Tokens. The very first specification for JSON Web Tokens was created December 27th, 2012, so very early 2013. And basically nobody touched these things or used them until mid-2014 when the first real blog post was published about JSON Web Tokens. Until then, these are basically completely silent on the internet. So they're only a couple years old. Now, the next thing to know about JSON Web Tokens is that if you've ever tried to implement them or build out what I've been talking about here, you'll notice that it's sort of a lot of work. You have to install a JSON Web Token library, you have to figure out how to store it inside of local storage, you have to figure out how to decode the token and store things inside of it and validate it and do all these things. So it's not exactly a thoughtless process. Now, comparing that to session cookies, they've basically been built into every single web framework since 1994, and they have zero effort to use. I've been to a lot of programming conferences. I can't think of a single conference in my entire lifetime that I've ever been to where there was a talk about how to use a session cookie. I'm just saying. It's pretty easy. So if I was keeping score of this right now, I'd basically say, hey, JSON Web Tokens have a score of 0, and session cookies have a score of 1. Now here's the thing. I actually do like keeping score of stuff. I'm sort of a numbers guy. But I have extremely bad short-term memory. So what I'm going to do is I'm going to say JSON Web Tokens, and I want you guys to shout 0. Come on. JSON Web Tokens? 0. Session cookies? 1. OK, cool. This is not too bad for 5:30 or whatever time it is. Now, next myth. JSON Web Tokens are a lot more flexible than sessions. This is an argument I hear quite frequently when people want to use these things. So let's take a look. Here is a JSON Web Token and what it looks like. This is how you define it. You just have some JSON data. Here is a session cookie with the exact same data inside of it. Now remember, session cookies are set by defining an HTTP header called set-cookie. You can put whatever information inside of it you want. So between both of these things, there's exactly the same data stored, key value data. And so basically there's no difference, right? Now, some of you who know a little more about JSON Web Tokens, as I was saying that, were probably a little frustrated because you're like, well, yeah, that's technically true, but that's not the flexibility we're talking about, Randall. JSON Web Tokens have all these really cool, interesting things called claims inside of them. And that's the flexibility most people are talking about when they talk about why they're more flexible. So let's talk about this. Claims inside of JSON Web Tokens are really nothing more than extra JSON data embedded in there by default. That's really all it is. And JSON Web Tokens, the spec for it, has a bunch of these things that are defined. Now, I'm picking 2 out of this as an example to show you. So here's 2 claims. The first one's called IAT, which is short for issued at. It tells you when the token was created as a Unix timestamp. The next one here is EXP, which is short for expires at. This is another Unix timestamp that tells you when the token actually expires. Now, these things are really awesome in JSON Web Tokens because it allows you as a developer to say, hey, once this user's logged in, their token, their identity, is only going to last for, let's say, an hour. Then they're going to be logged out of my website. That's pretty cool. But here's the thing. That same shit has been available in cookies since 1994 again. And so everybody's wrong. It's not more flexible. It's a lie. It's a myth. And so if we go back to the scoreboard, we have JSON Web Tokens with a score of? 0. And we've got session cookies with a score of? 2. OK. Next. This is another big one, especially in my industry, in the security industry. People love these things because they feel like they're more secure. So let's take a look at the track record here. Now, JSON Web Tokens. Let's talk about the good. First off, they're cryptographically signed. From what we've already discussed about cryptographic signing, it's pretty sweet. It's pretty useful, so that's great. And the other thing what's great about them is they technically can be encrypted, although almost never are. But we'll give them a point for that anyways. On the downside, however, the spec is incredibly complicated, especially for implementers building these JSON Web Token libraries. Now, I'm not specifically talking about JSON Web Tokens here. I'm actually talking about the family of specifications surrounding it called the Jose family of specs. This includes JSON Web Signatures, JSON Web Keys, and a lot of other things. And this spec is one of the most complicated things I have ever endured in my life. So I don't wish it upon anyone. Also, in the course of the last 2 years, there's been multiple massive vulnerabilities found in basically every single JSON Web Token library. And so the security track record is not super fantastic right now. It's still a very young, early technology. And finally, the worst part about it is that depending on what programming language you're using or what specific JSON Web Token library you're using, there can be a massive difference in the parity between what algorithms and what support for different parts of the spec each library has. This is a real pain point for me because I build a lot of applications that are partially in Python, partially in JavaScript, partially in Go or Java, things where there's different languages involved. And because these technologies are still so young, there are very few libraries that actually support the entire JSON Web Token spec. Now, if we compare this to session cookies, there's only a good column. Because basically, they are also cryptographically signed, are also encrypted, have been around since '94. There's been zero complexity in the spec. As a matter of fact, when I walked you through those header definitions earlier of set cookie and cookie, that's it, right? Super basic. There's been no vulnerabilities anywhere, and these things have been built into every web framework and every programming language since the beginning of time. So in terms of security, cookies have a far superior track record, and so, bam, let's go back to the scoreboard. We got JSON Web Tokens and session cookies. Okay. Next up, how many of you have ever been on a website and you see that little banner at the bottom of the page that says, hey, just so you know, we're using cookies to store your information, so click here to confirm or whatever. Anyone seen that before? All right. That's the result of the EU Cookie Law Directive, which was passed back in 2011. It didn't start getting enforced until 2012, I believe. And basically, a lot of developers think that JSON Web Tokens are a valid way to work around this legislation so that you don't need to put this banner on your website if you're building a website for EU customers. So I want to talk about this for a second. Now, here's the theory that I've heard people explain to me. They say that this cookie law basically requires you to display this banner on your website if your website uses cookies to store people's information, such as their login data inside of a cookie, things like that. And so the theory is that if you're using JSON Web Tokens and you're storing them in local storage, because that's not a cookie, you are no longer required to comply with this law. And this is the biggest misconception of them all because it's factually incorrect. Now, it's unfortunate because this law is named the cookie law. It implies that like cookies are somehow a bad thing. But the text of the cookie law is actually quite specific. And basically what it tells you to do is you need to put this banner on your site if you are storing data about the user that's tracking data, something that is not required for the user to log in. So if you're using Google Analytics or Optimizely or Kissmetrics or any sort of third-party ad or tracking network code, then you need to put this banner on your site, regardless of where that data is stored. Even if it's stored inside of local storage, it doesn't matter. You're required to show this banner. And as a matter of fact, fun fact, inside of the cookie law, there's actually wording which says user information used for login purposes is exempt. So you can store as much user information as you want inside of a cookie, and you still don't need to put this banner on your site. So it's just a bunch of myths. So going back to the scoreboard, we got JSON Web Tokens with 0 points. Session cookies with 4 points. Pretty cool. So next up, this gentleman over here said earlier, cross-site request forgery is a big issue, which it is. So let's talk about that. How many of you know what cross-site request forgery is? See a few hands, all right. For those of you who may not be familiar, let's do a quick recap. So let's say you have all your banking done on bank.com. That's what I use for banking, it's great. And you're logging in and you're checking your accounts, which is some pretty typical shit on a Friday. Now, next up, let's assume that your bank has a way to transfer money from your account to someone else's account, a transfer page. And on that page, there's an HTML form, and that form has 2 fields. One field is the amount of money you want to transfer, and the second field is the email address of the person you want to transfer the money to. Again, pretty common. But let's say you have a friend who's sort of a jerk, okay? And this friend's a web developer, obviously, because all the jerks in the world are primarily web developers, in case you didn't know. And this friend basically builds a little web page, and on that web page, there's an image tag. And the source of that image tag is actually bank.com/transfer, amount equals 1 million, and 2 equals jerk@gmail.com. And then your friend sends you a link to this web page to open up in Slack or whatever, right? So what happens when you click this link and you load up this web page? Well, I'll tell you what happens. You open the page. Your browser parses the HTML. It sees the image tag. It looks at the source of the image tag. It issues a GET request to bank.com/transfer, whatever. You are then issuing that request from your browser, which is logged into your banking website. So you go to the transfer page, and the bank developers, they're not the best. So what do? They take those query strings out of the URL, and they fill it in as form inputs. Then they submit the form. So what happens? Well, basically, you've been tricked by your friend into transferring $1 million into his account. That's basically cross-site request forgery. It's a really cheap, easy way to trick people into doing things on a website that they don't even know they're doing. By the way, what happens after that? Well, your friend definitely cash it, oh, well, the bank is gonna, of course, send the money, but then your friend's gonna cash it out for Bitcoin and leave the country. That's definitely what happens. So, here's the myth. People say the JSON Web Tokens prevent CSRF, and let's talk about why that's not true. Well, I'll shortcut you. I'll tell you the answer real quick. It has nothing to do with JSON Web Tokens. It basically has to do with where you're storing sensitive user information. So if you're storing sensitive information inside of a cookie, because cookies are automatically sent by your browser to a website, basically, you always will be vulnerable to CSRF. But if you store things inside of local storage, like a JSON Web Token, for instance, you've completely prevented cross-site request forgery from happening. And the reason why is because, again, local storage only works in JavaScript, and you have to write JavaScript code in order to send that to a website to log you in. So an attacker can't trick you into writing JavaScript code. They can only trick you into clicking a link. And so therefore, you're safe from CSRF. But here's the problem. A lot of people do this, and they don't realize that they've just made a huge mistake, which is that instead of fixing security problems, they actually open themselves up to a security problem that's way, way, way worse, which is XSS, otherwise known as cross-site scripting attacks. And so I want to talk about this for a moment. CSRF is a really easy pattern to fix. This has been known since 1994 when cookies were first started. This has always been a big popular attack vector on the web. And there's 1,000,001 ways to prevent CSRF attacks from happening. If you've ever used a programming web framework like Django or Rails or any of these big frameworks, even Node and Express, there's a way to do this. Pretty much by default, they all prevent CSRF attacks. It's really hard to actually do these things. So this has been a solved problem for a long time. But cross-site scripting, not so much. Much more difficult to prevent. Now, this is the Twitter Bootstrap documentation. Now, quick show of hands, how many of you have ever built a website where you copied in like Bootstrap CDN, jQuery CDN, Vue.js CDN, anything like that? Raise your hand. Now, I see there's some people not raising their hands, so we got some liars in the audience, because I know you've all fucking done this before. So I don't want to hear it. I know you've done it. Don't lie about it. It's okay. We're not going to judge you. Judgment-free zone. But here's the thing. That's really bad news for security, and the reason why is because every time you link to third-party JavaScript in your site, what happens if that JavaScript is compromised? Okay? So if you're hosting JavaScript code yourself, you can usually prevent compromise. What happens if you're linking to like some shitty analytics company's JavaScript code and their stuff gets hacked and someone modifies their JavaScript code to basically run on your website, because you're already running on your website, right? So their code runs on your website, and what does it do? It grabs everything stored in local storage, including your JSON Web Token, and sends it off to their API so they can collect your users' sensitive data. That's a really, really bad thing, which is almost impossible to protect against. And this happens a lot, by the way. So about 6 or 7 months ago, I was doing responsible disclosure with this large analytics company, and I reported to them that their public third-party JavaScript, which was CDN'd into probably tens of thousands of really large websites, could be publicly modified via an Amazon S3 bucket with the right permissions opened. So this is actually incredibly, incredibly common. This is by far the most common type of attack on the web today, and super easy to happen. Now, some of you might be thinking, well, you know, it's actually not a big deal, because if I'm building a website, I just won't use third-party JavaScript. And that's a legit thing. Like, if you don't use third-party JavaScript, you are safe. You can use local storage all day, but here's the thing. I pretty much guarantee you, you're unable to do this. And why do I say that? Well, if you're working in a company, you probably have other people working on your website. Usually marketing people or non-developers are going to be contributing stuff. And what do these people want to do? They want to track users. They want to use Google Analytics. They want to use Optimizely. They want to use all these tools, which are basically third-party JavaScript that require you to link out to their CDN. And so you can never really be safe of this. And you don't have to just take my word for this. So OWASP, the Open Web Application Security Project, is sort of the largest internet security think tank on the web. All the best researchers publish there, et cetera, et cetera. And this is a direct quote from their docs. Never store any sensitive information inside of local storage. So what does this mean to you? Well, this should mean that if you've ever read a tutorial telling you to store JSON Web Tokens in local storage, it was wrong. So you should run away and turn back, or run away and never turn back, sorry, because it's just bad information. And unfortunately, this information is widely propagated out there. So, going back to the scoreboard, we got JSON Web Tokens with a score of. You guys can do better than this, come on. And session cookies with a score of. All right, let's have some enthusiasm, people, shit. So next argument for people who want to use JSON Web Tokens, they say they're better for cross-domain authentication. So if you're handling a website with different types of login across multiple domains, this can be an issue. So let's talk about this. Let's say you have a public-facing website, www.website.com, and the user clicks the login button and wants to be logged in. That user is going to get redirected to login.website.com, because in this example, we're talking cross-domain, baby, different domains. And what happens then? That login domain is going to show you a login page. It's going to say, hey, what's your email? What's your password? Etc. So you as the user will fill in some information and hit submit, and that goes up to the server. The server is going to log you in. It's going to create a cookie for you. So you now have a cookie and you're logged into login.website.com. Then it's going to generate a JSON Web Token. And what's it going to do? This JSON Web Token is going to last for 10 seconds. And then this login page is going to redirect you with an HTTP 302 redirect to the dashboard domain. So now, in your browser, you see that you're at dashboard.website.com, token equals, and then this JSON Web Token. And then what happens? Well, this dashboard page is going to see the token in a query string. It's going to parse it out. It's going to validate the token. It's going to check that signature. And then what it's going to do is it's going to create a cookie and log you in on the dashboard domain. So now you have two cookies, one on the login domain, one on the dashboard domain. So you're logged into both of these places right now. And JSON Web Tokens have been used, but not for authentication purposes. They were used to help redirect. And finally, now that you're logged in, you are shown a dashboard page. And this pattern here works across anything, subdomains, top-level domains, as many domains as you want. This is the best possible way to handle cross-domain authentication while still using cookies. One of the reasons people think JSON Web Tokens are better for cross-domain is because cookies are typically bound to a single domain, but following this pattern works around that issue in a really convenient and simple way. And because we already know that JSON Web Tokens can't be stored in local storage, and we know it's not safe to do that, this is the safest way to use it. And this is not using JSON Web Tokens for the identity, this is using it for a trusted redirect. Now, let's go back to the scoreboard. JSON Web Tokens. Session cookies. Any questions about that, by the way? I feel like I lost some people. Sorry, that's what I forgot to explain. He's saying, why don't JSON Web Tokens get a point here? Because I use them. Well, sir, I'm talking shit about JSON Web Tokens in the sense that you shouldn't use them for web authentication. And this is not using them as identity information. This is using them to have a proven redirect. And secondly, I showed them here as an example of an alternate way to do that, although you could easily have used a cryptographically signed identifier regardless. That would have been more efficient anyways. And we're going to talk about that in a minute. But good question. So next up, mobile. A lot of people think JSON Web Tokens are better to use on mobile. Now, quick disclaimer. This talk, I'm focusing on JSON Web Tokens in the context of a browser, like web authentication. And here's the thing. This is the easiest one to explain because it's just patently false. And the reason why is because browsers on a mobile phone or a tablet work exactly the same as browsers on any desktop or laptop. So it's just BS. Bam. JSON Web Tokens, 0. Session cookies, 7. Awesome. Now let's talk about efficiency. So my background is doing a lot of low-level work, C and assembler and things like that. And so I get a little excited when we're talking about efficiency. Now, here's what I do. I like numbers, so I built 2 really simple applications. In one of them, I used the Node JSON Web Token library, the most popular one, to create a JSON Web Token just like this. It only has one piece of information, a session ID, which is this 40-character alphanumeric string. Then what I did is I took the same cryptographic signing algorithm, and I basically cryptographically signed that same alphanumeric string just on its own, without a JSON Web Token. And I compared how big both of these strings are at the end. So the JSON Web Token is basically 179 bytes, and the signed identifier is only 64 bytes. So what does that mean? It means the JSON Web Token to carry the same exact information is roughly 3 times larger in the best case scenario. Now, you might be saying this is minuscule difference because we're talking about a small number of bytes here, right? This is just a little bit of bytes. It doesn't really matter. But here's the thing. This is the best case scenario. Most people, when they're using JSON Web Tokens, they're using stateless JWTs, where all of your user information is embedded inside of the token. And so what did I do? I went back and I modified the example to add in some actual user information from some of the apps that I run. And what did I see? That in the real world, tokens are in the best case scenario 10 times larger, and in average scenarios, 75 to 100 times larger. So it actually ends up making tokens very large, well over 4 kilobytes, which means they cannot be stored inside of a cookie because they're now far too large. And what does that mean? It means they then have to be stored inside of local storage. And what do we know about local storage? That OWASP hates local storage, and it's garbage, and you should never use it to store sensitive data. And so the point is going to session cookies. So JSON Web Tokens now have a score of 0. And session cookies now have a score of? Sweet. We're almost done, you guys. Next up, people say JSON Web Tokens are easy to revoke. So let's say someone compromises your identity. How do you handle it? Well, let's say you log in and you get back a JSON Web Token and you're logged into a website. Then let's say that someone compromised your token because you're using local storage, and they start making requests to the website on your behalf. But let's also say that on your web server, you detect that something weird's going on, and you say, hey, you know what? I'm going to revoke this token from this user. I know what's compromised. So what am I going to do? I'm going to change the signing key that I'm using to create these tokens. Now, changing the signing key basically means you're changing your name. So if I were to mail you a bunch of letters, then all of a sudden I change my name, those letters that have my old name on it, you can no longer trust those. So what happens? Well, you've logged the user who got hacked out of your website, but you've also logged out every other user on your website. And that's a really shitty user experience. And so it's bad. Now, I've actually given this talk before, and someone said, hey, that's actually not true. Only a noob would do that. What we do is we use this common pattern called the token revocation pattern with a token revocation list. And so let's take a look at that. So every time you view a website, if you have a JSON Web Token, what a lot of people do in the real world is they say, well, you know what, I'm using JSON Web Tokens, but I want to be secure. So every time a user comes and talks to my website, I'm going to get their token, I'm going to check it against a central database or cache that I have to see if it's been blacklisted. And if it has been blacklisted, then I'm going to kick this user out of my website. But all I really have to say about that is like, what's up? Because the main benefit of a JSON Web Token is it's stateless. It contains all that information, so you don't need to talk to a database or cache on your backend. And guess what? Even if you're using tokens, you absolutely need to talk to a database or backend on your product to prevent this from happening. And so there's zero benefit, except you're now storing more bytes in the browser than necessary, and so it sucks. So JSON Web Tokens now have 0 points. Session cookies have 9 points. Awesome. We're almost done. I know you guys are getting tired. We're almost there. JSON Web Tokens are easier to scale. A lot of people think this, right? Let's take a look at the facts. On the good side, JSON Web Tokens, you can check their cryptographic signature and that they haven't expired locally. You don't need to talk to a database or any bullshit like that. But on the downside, this is only true if you have a stateless JWT where everything's embedded inside of it, and it puts a lot of effort on your user to pass more bandwidth from their browser to your website on every single request. Session cookies, on the other hand, they can be used, well, on the server side, you can do all sorts of cool mechanisms to speed it up and things like that. But the downside, of course, is they always require some sort of external database or cache in order to make it work. So these are the scaling arguments. Now, I think we've already talked pretty significantly about why you can't use JSON Web Tokens in most applications, because they're big, they have to go in local storage, which is a no-no, and all these other facts. So I'm going to skip re-explaining that to prove this point. Instead, I'm going to show you the right way to scale session-side backends. Because one of the things I've learned over the last few years is a lot of people have this, this misrepresented idea about how difficult it is to scale a session. People think scaling sessions is this really hard thing to do. That's bullshit. Super easy. So let's say you're building a website and you have a few thousand, tens of thousands of users a day checking it out. and users are visiting your site. Well, how do you make this happen? Whenever a user visits your site, you take their session ID, you check it against your database to find out who they are, and then you serve the request. This will work just fine. So if you're running a single server, a single database server like Postgres or Mongo or whatever the heck you're into, this works just fine. But let's say your website gets more popular, and now you have a few hundreds of thousands of users or millions of users. What do you do then? Well, it's basically the exact same thing, except instead of having one database, you horizontally scale and you have multiple databases. And again, this could be Postgres, it could be Memcache, it could be Redis. You can use an in-memory cache to speed this up a little bit, but the concept is pretty much the same. Now, in today's world, this is extremely easy to deploy. So if you're using Amazon, this is like a one-click. If you're using Heroku, it's like one click. If you're using pretty much any web hosting provider, it's like one click to do all this. And finally, what happens when you get real big? When you get to the size of Google, or Netflix, or Facebook, what do they actually do? They actually do this. So if you have hundreds of millions of users, you basically, I'm cheating a little bit, but what you do is you break your infrastructure up into different geographic locations, and you have inside of these locations clusters of caching servers to store this information in memory, and you make the same thing happen in a very simple way. And this is how it works in the real world at big companies. This is what they actually do. They don't use JSON Web Tokens internally, just FYI. So, going back to the scoreboard, JSON Web Tokens have 0 points, session cookies have 10 points, there's one more. And this one, I'm going to cheat a little bit. A lot of people think JSON Web Tokens were built for security purposes. And so this is me telling you that that is not true. Like, read the history about them, read the spec yourself. This is not what they're meant for. People have bastardized their usage. And let me point out why that is. When people log into a website using a JSON Web Token and do bad things, right? Well, let's say you log into a website and your token expires in an hour, but within that hour you start deleting users and doing malicious things, and so you get, you're banned basically from the website. They revoke your permissions. Well, if you keep talking to the website and say, hey, let me do bad things, then guess what? The website will let you do it, because the benefit of tokens, again, is you don't need to talk to an external data store to validate them. You do it locally using this cryptographic signature and all these other features. And this is a really bad thing for security. So in the security world, there's two things that are always true. It's called the speed-security trade-off. So you can either do things in a secure way, where you validate someone's permission every request they make, or you can do it in an insecure way, which is slightly faster, by just checking things out locally and caching it. And so people need to understand that JSON Web Tokens were not designed for this. They were actually specifically designed for a different use case. Now, we've covered all the bad things. Let's talk about how you should actually use these things real quick before we wrap up. Because you're probably wondering, well, what the hell? I heard all these great things about them, and I feel a little ripped off, and you're sort of right. There's two use cases I sort of like these things for. So first off is downloading files. Let's say you're building a website and you sell video files or HTML themes or whatever, and you want to sell them to users. So a user goes on your website, they pay for something, they want to download a video. Well, when you click that download button, your website can generate a JSON Web Token, embed inside of the token the file name that you're allowed to download that expires in 1 minute, and then it will redirect you to a file server so you can download that file. So if you're on like www.themeforest.net, you might get redirected to download.themeforest.net with a JSON Web Token in the URL. That web server can then just validate the JSON Web Token and then let you download the file. Now, what's important to note here, the JSON Web Token is being used a single time, it has a short expiration, and it's never being reused. Those are the things that make JSON Web Tokens useful. Single time use, short expiration. Now, the next use case that's really cool is password reset functionality. So let me walk you through this. If a user goes to a website and says, hey, I want to reset my password, and so what do? You say, okay, well, I'm going to email you a link to reset your password, and inside of this email, there's going to be a URL to my website, and it's going to have a JSON Web Token in that URL. And that token is going to be expired automatically in 30 minutes. So then when you go to your inbox and click that link, you're redirected back to the website with the token in the URL. The website is then going to parse that token out of the URL and validate it, make sure it trusts that this is good, and it hasn't expired. Then finally, it's going to let you reset your password. This is a great way to use a JSON Web Token, again, because it still sticks to those two laws. It's being used a single time, and has a short duration. It's not being used as identity proof. It's being used for a single time, short duration. This is the use case for JSON Web Tokens. Now, you might be wondering, with all the hype around them, why are they so popular? And this one's actually sort of my fault. So I'm calling out 3 companies in particular. So one is Stormpath, the startup that I used to previously work at. The other is Auth0, which a lot of you have hopefully heard of. They're a security company like my company. And the other is Okta, the company I work at currently. And here's the history of these things. The security industry is super fucking boring and slow. Nothing exciting ever happens, like ever. It's an incremental field where things barely, slowly fight and crawl their way to be interesting over decades and decades of use and research. And so basically nothing fun that really ever happens for us. That's why we're all bitter and boring and old. Now, when JSON Web Tokens came around, some people basically were thinking about, oh, well, how can we use them? What can we do that's interesting in the security world? And so they said, well, maybe we use them to like store session information. And so someone wrote a blog post about this. That blog post got sort of popular. And people started sharing it around. And basically everyone in the security industry hopped on this trend and said, well, that is an interesting use case. Let's play around with it. And what happened was that a few companies started doing this, Auth0 and Stormpath. And we all started promoting these things. And what did we learn? Well, both of our companies do one thing. We're both API services that operate to, and we basically store users for your applications. So if you're ever looking for an API service that like handles user registration, login, password reset, social login, all that stuff, either of our services will do that for you. And because our articles kept getting popular and kept getting views, we saw a lot of new users signing up for our services. And so we made a lot of money off promoting JSON Web Tokens. And so at the end of the day, the reason why JSON Web Tokens are so popular today is because over the last 3 years, both of our companies strategically use them as a way to market to developers, not based around any sort of like legitimate security concerns, but purely because it's a valuable marketing ploy in the security industry where this stuff is not happening very often. So this is why they're popular. And you can go verify all this stuff online. Now, what is my call to action for all of you today? Oh, actually, sorry. One final thing. If you want to verify this online, go to Google in an incognito tab. Search JSON Web Token and look at the first 10 results on Google. When I did this the other day, there's 1, 2, 3, 4, 5, 6, 7 of the 10 results on the first page are actually marketing pages designed to get you to sign up for one of our 2 services and give us money and outsource your authentication needs, okay? So I'm not just making this stuff up. Now, what's my call to action? Stop using these damn things, okay? You don't need to use them. It's easier and more secure to use session cookies. It's way simpler. You won't have to learn anything. They're super awesome, I promise. Nothing bad ever happened to people using session cookies. And thank you for being here. I know we went over. I really appreciate your time. You guys are amazing and super cool. And finally, in the event that you're super insane like me, you can always go get a I Hate JSON Web Tokens t-shirt on Teespring. So go for it if you want, just FYI. And thank you. I appreciate it.